In today's class, we discuss about the theories of light. They are corpuscular theory, wave theory, electromagnetic theory, and quantum theory. Several theories are proposed to understand what is light, how it travels, what are the phenomena exhibited by it, what are the theories, what are the failures of these theories, and what are the conclusions that we can draw from these theories. Light is a form of energy. Light is a form of energy and it will be emitted by a luminous body like sun. It travels as oscillating electric and magnetic fields. Oscillating electric field and oscillating magnetic field. The speed of these fields in vacuum is 3 into 10 to the power of 8 meters per second. In vacuum, 3 into 10 to the power of 8 meters per second. And in any medium, the speed is less than this. It passes through certain bodies known as transparent bodies. For example, if we look into a glass containing some liquid, we can notice the liquid inside the glass. It is because of the property of the light passing through the bodies, transparent bodies. The outside world can be seen due to the scattering of light. So when scattering takes place, the scattered light will enable us to see the external world. So we are able to see this external world because of light. Rectilinear propagation of light. That means light rays travel along straight lines. The traveling of light rays along straight lines is known as rectilinear propagation. Because of this property, sharp shadows are formed. Suppose if a man is standing, his shadow is formed. This is possible because of rectilinear propagation. Because of rectilinear propagation, the sharp shadows are formed. Similarly, solar and lunar eclipses can be explained basing on rectilinear propagation. In solar eclipse, the moon comes in between earth and sun. So the central dark disk represents the moon which comes in between the earth and the sun. So it blocks the sun. So a part of sun is seen. That white ring represents the light coming from the sun. The central dark part is the moon which comes in between the rays coming from the sun and the earth. So this shadow, this eclipse is formed because of rectilinear propagation of the light. So when we assume light to be traveling along straight lines, we can explain this eclipse. So reflection, refraction can be explained basing on rectilinear propagation. And the images formed by lenses and mirrors. See here, Taj Mahal image is seen in water. So this can be explained basing on the rectilinear propagation of light using light as rays. You have already studied about reflection, refraction, dispersion, etc. and also about interference, diffraction, double refraction, polarization, etc. Now I will introduce these concepts and I will recollect these concepts which you have studied. Interference is superimposition of two waves. When two light waves meet, then the superimposition takes place. The superimposition of two waves is known as interference. Diffraction is the phenomenon of bending. When light ray it falls near the edges, sharp edges, there will be bending of the light rays. This property is known as diffraction. When a light ray passes through certain crystal, then we notice two images instead of one image. This is double refraction. These are some of the properties. Now I shall list out the properties exhibited by light. They are reflection, refraction, interference, diffraction, polarization, double refraction, photoelectric effect, Compton effect, dispersion, etc. And when light falls on certain bodies, then light exerts pressure on the bodies, and sometimes the temperature of the body rises. These are the properties exhibited by light. Theories of light. Any theory that is proposed must be able to explain the phenomena which are noticed with light, the properties which we have studied. Those phenomena must be explained by any theory that is proposed. First, Newton proposed corpuscular theory to explain the properties of light. And then it could not explain all the properties. It could explain some properties but not all properties. Hence, another theory was taken up, that is Huygens wave theory. This also failed in explaining certain properties. Hence, electromagnetic theory was proposed, Maxwell's electromagnetic theory. It could explain some more properties. And finally, quantum theory was proposed. So, these properties, they almost explain all the properties exhibited by the light. Concepts of the theories. Corpuscular theory proposed by Newton, it imagined that light is composed of tiny elastic particles, like tennis balls, tiny elastic particles. And then Huygens wave theory, it proposes the light is composed of mechanical waves, like the waves on the surface of water. Then electromagnetic theory. Electromagnetic theory proposes that light is composed of oscillating electric field and oscillating magnetic field. So electromagnetic theory proposes that light is composed of oscillating electric and magnetic fields. And finally, quantum theory once again proposes that light is composed of wave packets. A group of waves will be taken up as a quantum, a packet, and is known as photon. Like this, we notice different concepts. Newton's corpuscular theory, it proposes light to be composed of tiny particles, elastic particles. And these elastic particles are emitted continuously from the source. Elastic particles are emitted continuously from the source. Hence, the source must lose some mass. These elastic particles, they travel with very high speed, and the speed of this particle depends on the temperature of the source. The speed depends on the temperature, and the color depends on the size of these elastic particles. We notice different colors of light. So he explained that color depends on the different sizes of these elastic tiny particles. He proposed that light travels with greater speed in denser medium. According to this corpuscular theory, light should travel with more speed in denser medium. But of course, it was proved to be wrong by Foucault's rotating mirror method. These are the concepts proposed by Newton's corpuscular theory. Now, success and failure of Newton's corpuscular theory, that is, what are the phenomena that are explained by this theory and where it failed. Newton's corpuscular theory can be used to explain reflection, refraction, and dispersion. These three properties can be explained. Reflection, refraction, and dispersion can be explained using Newton's corpuscular theory. But it fails in explaining all other phenomena exhibited by light. So Newton's theory fails in explaining interference, diffraction, polarization, photoelectric effect, double refraction, etc. In explaining these phenomena, Newton's theory fails. Huygens wave theory. Huygens proposed the wave theory, and his propositions are: the light is composed of mechanical waves, that too transverse mechanical waves. Without any reason, he proposed them to be transverse mechanical waves. And these waves, they are emitted from the hot source. Transverse mechanical waves are emitted from a hot body. And for the propagation of these mechanical waves, a material medium is necessary. For the propagation of transverse mechanical waves, a material medium is necessary. So, he imagined a highly elastic medium, a medium with high elastic property. Young's modulus is very, very high, and the density to be very, very low. To get very high velocity, he imagined a new medium, and he called it as ether. So a new medium called ether was proposed with the properties high elastic property and low density. Because for the propagation of transverse mechanical waves, a medium is necessary. He imagined a medium, and this medium is present everywhere in the universe, including the space between the protons and electrons, neutrons, etc. In fact, for the propagation of transverse mechanical waves, elastic solid medium is required. So an elastic solid with high elasticity and low density is required for the propagation of these mechanical waves. In fact, it was proved that light can travel in vacuum. It was proved that light can travel in vacuum. And Michelson-Morley experiment disproves the existence of ether. Michelson-Morley experiment, it proves that there is no medium like ether, because they found that the speed of light is same in all directions. And it also proves that there is no longitudinal component in the waves, in the transverse mechanical, in the mechanical waves, there is no longitudinal component. These facts are proved by experiments. Huygens principle. He proposed a concept known as wavefront for understanding the propagation of light when it is traveling in the form of waves. This principle is still used. We can define it as the locus of all particles whose phase is the same. Consider a source of light like a bulb. Consider it as a point body. Then the light waves that are emitted from this surface, from this body, all of them reach the surface of a sphere simultaneously. So the particles situated on the surface of the sphere, they will be in the same phase. Hence, the sphere is considered as the wavefront. For a point source, the wavefront is spherical, like a sphere. Moreover, Huygens proposed that the points on the surface of this wavefront, I have shown 3 points on this surface. Like this, imagine several points on the surface of this sphere. All the points on the surface of the sphere, they act as sources of light. They emit waves. They are known as secondary wavelets. These waves are known as secondary wavelets. So the points on the surface of wavefront act as sources of secondary wavelets. These wavelets, they will not travel in the backward direction. They will travel only in the forward direction. Like this, light will be spreading. And once again we will get another wavefront, which will also be a spherical wavefront. So for the propagation of, for the advancing of light, to understand the advancing of light, we use this concept of wavefront. Electromagnetic theory of light. To understand this theory, first we have to understand the directions of these vectors. We represent the electric field vector by the letter capital E, and the magnetic field vector by B, and the velocity of the light as V, that is, the speed is V. Now if we consider left to right is a line which is x-axis, that is the direction of flow of the light. Consider a plane perpendicular to the screen and into and out of the screen, that is the plane in which B is situated. Imagine a plane horizontally into this screen and out of the screen. that is the plane in which the vector B is situated. And the vector E is situated in the plane of the screen, and it will be moving up and down. So the electric field vector will be varying in the up and down direction. Magnetic field vector will be varying in the horizontal plane, moving into and out of the screen. And the light will be propagating from left to right. These are the directions of the three vectors. We notice that in the first loop, the arrows are parallel to E. In the second loop, the arrows are parallel to, downward arrows are parallel to E. In the first loop, upward arrows. In the second loop, downward arrows. And in the third loop, upward arrows are parallel to E. In the first loop, downward arrows are parallel to B. In the second loop, upward arrows are parallel to B. And in the third loop, downward arrows are parallel to B. This indicates that the direction is changing continuously. Moreover, the magnitude is also varying, that is indicated by the curve. In the loops, the curves are given. That curve indicates that the magnitude of the electric field vector is increasing and then decreasing from 0 to a maximum value, and then it goes to a minimum value and comes to 0. Like this, the magnitude will be changing continuously and the direction will also be changing continuously. E and B are situated perpendicular to one another, and they are time varying fields, and the flow of energy will be perpendicular to the direction of variation of these two fields. This is electromagnetic theory. Just now we have seen that the light ray consists of oscillating electric field and oscillating magnetic field. According to electromagnetic theory, light is composed of oscillating electric field and oscillating magnetic field. Oscillating means time varying. The time varying electric field produces magnetic field. The time varying magnetic field produces electric field. So, while oscillating, one field produces the other. Like this, the wave will be propagated continuously. The sensation of sight is due to only electric field intensity. Magnetic field intensity has almost negligible effect on the sensation of sight. And we propose two properties for the medium. One is magnetic property, the other one is electric property. The magnetic property of a medium is termed as permeability and is represented by mu. The electrical property of the medium is termed as permittivity and it is represented by epsilon. These properties are such that they give the speed of light. For example, speed of light V is equal to 1 by square root of mu epsilon. The speed of light is given by the product of these two properties, electrical property and magnetic property. The speed of light V is equal to 1 by square root of mu epsilon. So when we consider vacuum, 1 by square root of mu 0 epsilon 0. If mu 0 epsilon 0 are the magnetic and electric properties of vacuum, then 1 by square root of mu 0 epsilon 0 is equal to 3 into 10 to the power of 8. Like this, we notice properties of a medium. Electromagnetic spectrum. Electromagnetic spectrum. Electromagnetic radiation is discovered in different processes and it is named with different names in different regions. First, let us recollect the names that are given to this radiation. Power waves, radio waves, microwaves, infrared, visible, ultraviolet, X-rays, gamma rays. These are the different names that are given to electromagnetic radiations of different ranges. These electromagnetic radiations, they can be represented on a paper either in the increasing order of frequency or in the increasing order of wavelength or in the decreasing order of frequency or in the decreasing order of wavelength. Any of these arrangements is known as an electromagnetic spectrum. So an electromagnetic spectrum is the arrangement of electromagnetic radiation in an order. Here I am using increasing order of frequency. It is same as the decreasing order of wavelength. I am showing here the increasing order of frequency and decreasing order of wavelength. The values that are assigned here are only approximate. The ranges are only approximate but not exact. Remember that these values are only approximate values. Now let us take one by one. Here the upper scale starts from 10 to the power of 2 to 10 to the power of 22, that is frequency. The lower one, it is from 10 to the power of 6 to 10 to the power of minus 14. It is wavelength in meters. The upper one is frequency in Hz, the lower one is wavelength in meters. Let us take one by one. When we consider power waves, its frequency changes, varies from 10 to the power of 2 to 10 to the power of 3, and its wavelength 10 to the power of 5 to 10 to the power of 6 meters. Radio waves, its range is 10 to the power of 3 to 10 to the power of 7 Hz frequency, and the wavelength 10 to the power of 2 to 10 to the power of 5 meters. Microwaves, frequency ranges from 10 to the power of 5 to 10 to the power of 8, and the wavelength from 1 to 1000, 10 to the power of 3. Infrared, 10 to the power of 8 to 10 to the power of 12 frequency range, and wavelength range is 10 to the power of minus 3 to 10. Ultraviolet radiation, visible radiation, its frequency is from 10 to the power of 11 to 10 to the power of 15 Hz, and the wavelength is 10 to the power of minus 6 to 10 to the power of minus 3 meters. Ultraviolet radiation, it is from 10 to the power of 14 to 10 to the power of 18 Hz, and wavelength is 10 to the power of minus 9 to 10 to the power of minus 5. X-rays, 10 to the power of 18 to 10 to the power of 12 Hz, and wavelength 10 to the power of minus 10 to 10 to the power of minus 8 meters. Gamma radiation, it is from 10 to the power of 20 to 10 to the power of 22 Hz, and wavelength is 10 to the power of minus 14 meters to 10 to the power of minus 10 meters. Like this, we can assign some values to the wavelengths and frequencies. So these these radiations arranged in a particular order is electromagnetic spectrum. Quantum theory of light. According to this theory, light is emitted in the form of energy packets by the source, known as photons. The quantity of energy is called photon, and the energy of each photon, each particle, is h nu, where nu is frequency. Or if lambda is the wavelength of light emitted, then the energy of each packet, photon, is E is equal to hc by lambda. We can imagine this particle to be composed of a group of waves. First we see a small particle. If you slightly enlarge it, you will notice the second one. Another large magnification gives still bigger one. Like this, if we proceed, we notice it is composed of groups of waves. This theory was first proposed by Max Planck while working on black body radiation. While working on heat on black body, this concept was proposed by Max Planck. Einstein borrowed that concept and applied it to the light while explaining photoelectric effect. For explaining photoelectric effect, Einstein adopted this quantization concept from Max Planck. Like this theory comes into existence. Now, the successes and the limitations of different theories. Corpuscular theory, it could explain reflection, refraction and dispersion, but failed to explain all the remaining phenomena of light. Next comes wave theory. Wave theory could explain interference, diffraction, along with reflection and refraction and dispersion, but failed to explain double refraction, polarization, photoelectric effect. Let us pass on to the limitations of other phenomena. Electromagnetic theory could explain polarization and double refraction. Electromagnetic theory could explain polarization and double refraction, and it proved that light is a transverse wave. And then it could not explain photoelectric effect and Compton effect. That was done by quantum theory. Quantum theory could explain photoelectric effect and Compton effect. By combining all these theories, finally we conclude that light is treated both as a wave and as a particle. For explaining certain phenomena, we take light to be composed of waves, and for explaining some other phenomena like photoelectric effect and Compton effect, we treat light as photons, particles. So we say it has got dual nature, both wave nature as well as particle nature. Now let us summarize what we have studied so far. Light is a form of energy. It travels in the form of electromagnetic wave with a speed 3 into 10 to the power of 8 meters per second in vacuum. In other medium, its speed will be less. It is considered both as particle as well as a wave, so it is called dual nature. It exhibits several phenomena: reflection, refraction, dispersion, interference, diffraction, polarization, double refraction, photoelectric effect, Compton effect, etc. We see four theories which explain the light, nature of light. They are the corpuscular theory, wave theory, electromagnetic theory, and finally quantum theory. First attempt was made by Newton, and he proposed corpuscular theory, which explained reflection, refraction, and dispersion. But it failed to explain phenomena like interference, diffraction, etc. Then came the necessity of another theory. Then wave theory was taken up, and it was useful in explaining interference, diffraction, in addition to reflection, refraction. But it also failed in explaining some other phenomena like photoelectric effect, Compton effect, polarization, etc. Then Maxwell has proposed electromagnetic theory, which enabled to explain polarization, double refraction, etc. But it also failed in explaining photoelectric effect and Compton effect. So there was necessity of another theory, and finally quantum theory could explain these concepts. Like this, we come to the dual nature of light. Answer the following questions. What is light? How it travels? What is its speed? Can it travel through vacuum? What are the theories that are proposed to explain light? What are the phenomena exhibited by light? Explain the scope of each theory. What is Heisen's principle? What is an electromagnetic spectrum? Sketch the electromagnetic spectrum. What is a photon? What is the present concept of light? What is the relation between speed of light and the properties of the medium? diagrammatically explain the propagation of electromagnetic wave. What is the wave front? How can you locate it?